Hello, everyone. Welcome to PTRE 475-575. My name is Andreas Michael, and I will be the instructor of this course. I'm an assistant professor here at University of North Dakota since 2023. I believe we only have online students enrolled in the class. We should have 8 or something, which makes a fairly big, fairly okay size class. Yeah, I'm gonna be the course instructor for this spring. I did meet some of you the year before. I know some of you I had email exchanges with. So most of you I know through some capacity. Some of you came over for labs on campus that I was teaching last summer. So I know some of you, and some of you already know me. I was supposed to teach geomechanics last semester, which is the class that precedes this one. I did not. Richard Schultz taught geomechanics, and it was, but I know he used my material, so it should be quite simple transition-wise. So yeah, I mean, the classroom that they gave me is the computer lab. That's why you see a lot of computers. But yeah, given that there is no on-campus student enrollment, I mean, it's just gonna be me. The exams would be online via ProctorU, or you can sign a waiver and take it in person from a pre-approved location near you. We'll talk about it when the time comes. There is also a term paper in this class that we'll discuss as we go along. And there is also something like 5 homeworks and 2 exams. It's a cross-coded exam, a cross-coded class. The undergrads are taking PTRE 475, which is well completions. The graduates are taking 575, which is advanced stimulation techniques. When there is a cross-coded class, there is some difference between the students from one course to the other. In this one code to the other, I guess. In this class, the difference is in the term paper. We'll discuss it as the time comes. Anyway, so let's see, I'm sharing the screen and I am recording. So this morning I was teaching my other class, advanced drilling, and there was some issues with Blackboard. It took a while to load. And there was a moment that I should have been sharing screen, and actually I wasn't sharing. But yeah, I mean, a little bit of an issue. If there is anybody online, please feel free to stop me. You don't need to raise your hand or anything. Just speak up and it will be fine. It's not a big class. So course description. This is a description in the website about the class in our department's website. I'm not gonna go through reading it. It's more or less accurate. And this is the description for the advanced class. Quite similar. And there are some prerequisites. The undergrads need to have taken production engineering and passed it with a grade of C or higher. Now, the graduate students need to have good background and knowledge in drilling engineering. This is quite subjective sometimes. It happened to me that I had students with a background in petroleum engineering whose background on drilling engineering was actually not good. It it really depends, but I would say if you're a graduate student, probably geomechanics is the most important thing. Or drilling stuff related to geomechanics is what we really need. And the best prerequisite for this class is to have taken PTRE 465 or 531, which is the petroleum and reservoir geomechanics classes, which is the one that Dr. Schultz taught last semester with my material. Let's see. If you go to Campus Connection, go to my website, Andreas Michael. My UND website, okay? Click on me. Go to courses. If you click this link that says Fall 2024 for Petroleum Geomechanics, it will direct you to a private YouTube channel playlist with the videos from the lectures from the last time I taught the geomechanics class. So if you feel like we have deficiencies as the class is going on, feel free to go to those videos and watch them. That will help you fill up those deficiencies and cover any gray areas. That will sort of sort it out. I also have links to the drilling engineering classes. So yeah, if it's gonna help, if you feel like I'm moving too fast in the course or that I'm covering material that you should have known and you don't, I think this is the way to go. Go watch those videos. Let's see. So, always difficult when there is no audience. But anyway, my name is Andreas Michael. I guess most of you already know me. I was born and raised in Cyprus. Boys from where I come from are mandated to do 2 years of military service after high school, which I fulfilled during the years 2008 to 2010. I believe now this has been reduced to 14 months, which is good. It has been 2 years since forever. After that, I came to the US in 2010. I got my bachelor's from the University of Texas at Austin in 2015, 1 semester early, and then my master's in 2016, 1 semester late. I stayed for 2 more years in Texas, and then I moved to LSU, Louisiana State University. I got my PhD in 2020. All the degrees are in petroleum engineering. In 2019, in Calgary, I was the captain of the Petrobol team that won the championship that year. And the next day, I placed second in the International Student Paper Contest for PhD division of SPE. Generally, a PhD dissertation contains material from 3 peer-reviewed journal papers. I wrote 6 from my PhD. So for that, I got the Distinguished Dissertation of the Year award for STEM in the year 2020 from the entire university. They give 1 award for STEM, best dissertation in STEM, and another one non-STEM. And I got the one that was for STEM. Last year, with one of my graduate students, Abdel Malek Abeth, I received SPE's Cedric K. Ferguson Medal, which is a pretty prestigious award because it's not an award that you get nominated for and you win it. It's an award that you get nominated automatically and you get decided from the entire pool. That is the best paper, the best PR-approved paper written primarily from people under the age of 36. I was 34. The student was something like 27 or 28. I think he was born in 96. So at the time we published this paper, and it got selected last year for this award. Malek is gonna be graduating this semester with his PhD. A very, very smart student. I have authored or co-authored 19 peer-reviewed journal articles, 37 conference papers, and 18 magazine articles. Almost all those magazine articles, all of them but one, came from where with SP is the way ahead, which is SP's magazine for young professionals. It's a digital publication. Young professionals, again, under the age of 36. For the year 2020, 2021, I was the editor-in-chief of that magazine. And it was the best year the magazine ever had in terms of page views and readability. I really enjoyed that job, actually, even though it didn't pay, it was a volunteer position. They work with something like 55 editors from all over the world. Now, if you are interested in writing scientific content, I don't know anybody there in the leadership team right now, but I can help push you in. They are always looking for good, diligent volunteers that are eager to work. So that about me. The next slide is about our TA. Oh, sorry. The next slide is about the course sequence. That class is a series of 4 classes that you take during your spring semester and the fall semester. You take from me. You take drilling engineering in fall of your junior year. You take advanced drilling in the spring of the junior year, and then you take geomechanics in the fall of the senior year. And lastly, you take this class the spring of your senior year, just by the time you graduate, when you finish with senior design courses, etc., etc. My fall courses, fall semesters are shorter, so they have only 4 modules. And the spring courses have 5 modules. This one has 5, okay? Basic road mechanics, which is geomechanics review, well completion hardware, hydraulic fracturing operations, formation damage and well deliverability, artificial lift and surface facilities. And this is what we are gonna do now. Undergrads is easier because they force you to go through this sequence. They force you to go, let's see. They force you to take it in this sequence of 1, 2, 3, 4. Graduate students, it's a little bit more free, okay? That means somebody can try to go, and they have tried to go this and then this. This is not the best idea because what really happens is that you have a tough time here and you have a very easy time here. You need this to get this. And yeah, it's a little bit going against the current, which sometimes is unavoidable. That's why I make those videos available to you guys from the last time I taught that class. So that, especially module 1 is basically geomechanics review. So generally students tend to find difficulty in that first module. Second one is easier, more straightforward, more operation-based. The third one is big, and it's mixed. And then the fourth one is a lot of stuff that you should already know from production. And then the last one is a small one but important. Also production. Well completions, as a sub-discipline of petroleum engineering, has a lot of overlaps. Okay, it has overlaps with drilling, and we cover those in module 3 of 411, which is casing design and cementing. And we cover some here. We cover some here, wellbore mechanics and directional drilling in advanced drilling engineering class. But then we also have a lot of overlaps with stimulation, which we cover in module 3. We have a lot of overlaps with production, which we cover in module 4 and some in module 5. So well completions has a lot of overlaps. So you need to be very, very interdisciplinary when it comes to this stuff. Okay, so now our teaching assistant. If you took a class with me the last year and a half, probably you had Kalu as your TA, who's an amazing student from Nigeria. He's doing experiments on hydraulic fracture modeling in gelatin blocks, highly concentrated gelatin. If you mix it properly, it starts resembling a scaled version of the properties of rock, reservoir rock. In fact, if you mix up the right conditions, it starts resembling body. Like many people use concentrated gelatin for ballistics testing as well. So it has a lot of usefulness, especially in the fact that it can be transparent. So you can see through it and you can see the fractures growing and you can understand some things about fracture mechanics that you may not be able to model mathematically or computationally. He should be getting his master's either at the end of this semester or next August. He's a very smart guy. He will carry for a PhD later on. He's always approachable. Please treat him with respect and professionalism. He's expected to do the same. I'm expected to do the same. Yeah. So, always available. His information is on the syllabus file, which I should be able to open. I wasn't able to open the syllabus file of the other class earlier this morning because of the Blackboard issues. Yeah, I mean, very, very useful. It's a resource for you guys. It's certainly a credit for our department and certainly a credit for our university students like Kalu. Make sure you use him, okay? He can help you. Class format and important dates. So the class will consist of homework assignments that are expected to be something like 5, maybe 6, maybe 4, that make 25% of the course grade. Okay, 25%, quarter of the class grade is based on the homeworks. This is an important part of the grade, but it's not the only important part of the grade. It's a part of the grade that you do have a lot of control on. Okay. Then there is 2 exams, one on Tuesday, March 3rd, and one on April 16, Thursday. They are worth 30% in total, so 15 each. Importantly, they are worth, each one is worth 15%. The homeworks are worth 25%. So this is done to help you, not to help me or the TAs, to help you balance out a maybe mediocre performance in an exam. So take advantage of it. Okay, is to help you. Then we have the class project that is due the last day of class and is worth 20%. We're going to talk in more detail about that after module 1. I will have you choose a topic that is related to your class. So 475 people must choose a well completion related topic. 575 people, graduate students, should choose a stimulation techniques topic. And you will write the term paper in the format that I suggest you do, or that I mandate that you do, and you get graded for that. But it's not a normal term paper as they do in other classes that basically you can mold in a way that looks good, even if you don't know what is going on. This is a serious term paper that has to have a certain structure. You have to arrive to a novel hypothesis. We'll discuss that when the time comes, but it's a serious part of the grade. And it's really because we have graduate students in the class, we have undergrads that are towards the end of their undergraduate degree. So you guys are at the level where you should be able to formulate a hypothesis on a topic that is testable and can be tested. Now, I'm not expecting you to do research work for that. You are proposing something, okay? So, but you need to propose something that is realistic, that can be done. You cannot be like telling me stuff that either cannot happen or won't happen or can happen without like a miracle, like $1 million falling from the sky, or some experiments giving you results that are basically highly unlikely. Now, the exam dates are a little bit, how do you call it, tentative. I need to get it approved by the ladies downstairs. But the class project is due the last day of class. That's the latest I can ask you to provide me an assignment with, provide me the submission for. That's why it's the last day of the class. By the way Blackboard is due when the last minute of the day starts. That's how it is. So don't wait until the end of the last minute of the day. Submit it before the last minute of the day begins. That's how Blackboard is. Same thing with the homeworks. I have this rule that if you submit the homework late and I haven't yet posted the solution key, you get it 50% discount. So if you get 100, it's going to be 50%. It's going to get 50 out of 100 on the records. If you submitted it late, but I haven't yet uploaded the solution key. If, however, I already uploaded the solution key, then there is no point in you submitting the homework. It's all over. You're going to get a 0. So make sure I try to keep this rule, and I let you know in advance, also from the syllabus, 50% rule. If the solution key has been uploaded, and you submitted your homework late, anything you get, if the solution key hasn't been uploaded, and you submitted the homework late, anything that you get is discounted by 50%. If the solution key has been uploaded, don't bother. 0. And also bear in mind that, this is not the kind of class that you can avoid doing the homework and pass it, because 25% is an important portion of the grade. And finally, on May 12, 1 to 3 p.m., we are going to have our final exam, which is also worth 25%. Again, administered via PTRE. And there is nobody on campus. If there was somebody on campus, it would be here. But now, with PTRE, I'm basically giving you 24 hours to take the 2-hour exam or the 75-minute midterm exams. The midterm exams are going to be 75 minutes. The final exam will be 2 hours. Okay, so I said that in the other class too. It's a serious class, okay? And the best way to approach it is like a boxing match, okay? First rounds, homeworks, get as high grade as possible, build a nice average grade as you go along with the homework, which you do have a lot of control on. You almost have infinite amount of time to work on it. You can ask for help. You control a big portion of that grade, 25%. Then the midterm, maybe the first midterm, you are not used to me as an instructor yet. Some of the concepts are new. You don't do very well in the first exam. Okay. Then the second exam, you do better. The term paper, again, almost full control. You start it as early as possible. As soon as I give you guys a prompt, the document after the first module, you start working on it. You do a little bit of work every day, and you don't leave it until the end. Then you do well on that, and then the final, you go into the final with the best chance to get an A in the class. And even if the final is hard and you don't do as well, it won't drop you lower than that. That's the approach that you need to have in this class. It's going to be a semester-long battle. Course modules, I already described them. Generally, from what students tell me, they don't like the first one. They like the second one. They like the third one. They are okay with the fourth one, and the fifth one is fairly short. That's more or less what I thought myself when I was a student, to be honest. Yeah, I mean, some things we can change. That's how it is. I like the third one actually quite a bit. And that's the longest one. So now I have been teaching. This is the, let me see, 1, 2, 3. This is the 5th time I'm teaching this class. Okay, I taught it 4 times during a spring semester. Well, counting this one. Then 1 time during the fall semester asynchronously. So I have seen a lot of students. Well, maybe not a lot of students as a number, but I have seen a lot of students in general. And sadly, there are some common issues that are the causes of getting a bad grade in the class. So I try to come up with them, mention them in advance to prevent you guys from doing them, hopefully, so that you don't get a bad grade on the class. So many times you don't have adequate background, okay? You come to the class, you don't have the right background. Obviously, the things are going to look very hard and going to be very hard to grasp. Sometimes you do have adequate background, but it's weak. That means you took the class that you are supposed to take. You didn't do very well. You didn't understand the material, but okay, the instructor passed you, or you got some help. You had a helpful classmate that helped you with the homework or something. Yeah, and somehow you got through, but you didn't really learn what you had to learn. That's the second cause. The third cause is a very sad one, very common, inconsistency, okay? That's why I took it, I said the boxing analogy. You don't get a low grade because you did bad on a hard midterm. A hard midterm, everybody will do bad, okay? And that won't damage you particularly. You get damaged if you overlook an easy homework where everybody does 100 and you get a 0 for that. That's when the problem is. If it's something, if it's a hard exam, it's hard for everyone. But the easy homework that you overlook and you don't do, and everybody does 100 on, and you get a 0. I mean, a 0 is 0. So this is quite, you need to be committed. It requires, this class will require your commitment throughout the semester. It's a serious class. You are just about to get a bachelor's of science in petroleum engineering, some of you, at the end of the semester. You are going to be going out calling yourselves petroleum engineers. You need to know what you are talking about. The fourth cause is drowning in the details and missing the big picture. It's something that I struggled with a little bit when I was young. Think of it, these are operational classes. They are very applied, very, very applied. So think about it as a tree. And you have the thick branches, and you have the thin branches. And the thick branches are more important than the thin branches, or the details. Don't overlook the thick ones for the thin ones, you know? You need to take it in a hierarchical fashion. Some things are more important than others. That's what I like to say. The fifth one is very sad. It's low motivation. There is people who just want to pass the class. That generally puts them into a situation of a where you're on the fence. Okay, if you're on the fence and you all into a final, the final is hard. You don't pass the class because you did bad on the final, and you could have done better on the homework and have some margin, and suddenly you miss your graduation because you didn't do well on the final. It's sad. Don't let this happen. Anyway, so this is what I wanted to talk about for the class logistics-wise. Now I will try to open the syllabus. If Blackboard allows us, it's going to show you more or less the same stuff. If you go to start here, course overview, syllabus. Okay, I have it here. Okay, my office hours normally were Tuesday 12 to 3. But this year they moved my class from Monday, Wednesday, Friday to Wednesday only, 11 to 2. Sorry, Tuesday, Thursday, 12:30 to 1:45. So I had to move my office hours. So this is wrong, actually. It says Tuesdays, Wednesdays. I will fix it. So I will fix it. So I was on a road trip to Colorado. I was at a hotel in Grand Junction when I was doing this. I missed it. Okay. So Wednesdays 11 to 2, and I have a Zoom link that I shared yesterday with the announcements, and it's also available in the Zoom tab that I mentioned in the announcement. That you can use to join me, or you can come in person, of course. Now, the truth is, office hours is anytime you see me that I'm not preoccupied with something, then you feel free to ask me, please, or shoot me an email, send me call me, send me a text. Any way you can reach out to me, smoke signals, any way that I can respond to would be okay. Yeah, modules, we talked about those. Now, the class material, I mentioned some books. You don't have to buy them, okay? They are not mandatory. but they can be very useful. Especially this hydraulic fracture mechanics is a very famous book by Valco and Economides. One of my favorite petroleum engineers. Probably the best one of his generation. He passed on something like 12 years ago. But he was very big. He was a professor at University of Houston. Valco was one of his postdocs, I think. And then we have the book, the Beam Lift Handbook by my own professor from Texas. I took like Paul Bomer. I took something like 7 classes from him. He was teaching us all the applied classes in the program. He taught us drilling, senior design, artificial lift, production, surface facilities, one more I don't remember right now. He was very, very, he was teaching like 4 classes a semester. One semester he got sick, literally. He was like overexhausted. They were overworking him, I guess. But yeah, a very, very practical person with 25 years of experience with his own company after getting a PhD. So he really knows what he was talking about. It's a very, very good it's a very good book for anything production related, I would say. It goes beyond the beam lift. Very useful book, very useful book. And Well Completion Design by Bellarpi is a fairly general book for well completion design. I would say it covers what it needs to cover, but it's not particularly phenomenal. The other 2, I would suggest that you guys have them in your library. By the way, there are online versions. I have seen PDF versions of those books, and I have them. I just cannot share it with you guys. It would be illegal if I do so. But hydraulic fracture mechanics, I use it a lot for research. And yeah, the beam lift handbook. I even know a story of somebody that he was called by somebody in Midland to help with he had an issue with his design, the design of his circuit rod installment in his well, and somebody went by there with this book, helped him redesign it, made some money, and left. You know, it's very, very useful. It has a practitioner value. That book. I have it in my office, and I regularly consult it. Okay. The rest, I think, I don't think there is anything else you need here other than homework assignments, 25%. Okay, there might be quizzes. If there are quizzes, it's going to count as a homework. Okay, midterm exams, 15% each. Term paper, 20% each. 20%. Final, 25%. I will let you know when the dates of the midterms are finalized. And I cannot change the date of the final. It's set in stone by the university. The grade breakdown, I wouldn't, I told you already, most of you already took classes with me. You know I dropped the cutoffs lower than what is. This is just what UND recommends. It doesn't mean that we have to abide by it. I have moved the cutoffs down. I never moved them up. So generally, I rank the students from the highest grade to the lowest, average-wise, weighted average, and then I try to find some nice gaps. And I put them accordingly. Yeah, undergrads need at least a C to use this class for a degree. Graduates, I think it's a little bit different. Yeah, I mean, we'll talk. I don't do extra credit. So don't come and tell me I'm doing terribly. Can I get extra something? Can I do something for extra credit? Make sure you do well and know that generally, if you really do well, I can help you with. If it makes sense to drop the cutoff a little bit for some people to go over it, I do that. Also, something else is that when I'm about to give grades, I consult the TA. I tell him, shall I put the line between this person and this person? What do you think about? I always consult the TA about the grade cutoffs. Also, because it's very likely that the TA might know the students more than me. If you happen to consult the TA mostly than me, which is fine. Course evaluations will be handed at the end of the semester. They are called selfie. I would highly recommend that you do it and you are, to be honest, if there is something that you think the instructor can do better, be honest about it and try to be, how do you say, not detailed or instructive enough. Try to be like, okay, if you do more of this, less of that, things are going to get better. Yeah. It's very like, I would be very responsive to those next time I teach those classes. So, yeah. And the material for this class was developed back in 2023, but it has been improved over the, every time I was teaching the class, I'm finding a mistake or something in the slides, I fix it, etc., etc. Now, I noticed that before the beginning of the class today, I did not upload all the modules, but I will upload them. And they're going to be here where it says lectures, module 0, and then you click on it and you have PowerPoint slides, and then underneath, I'm going to be putting the video of every lecture. That video is an MP4 file that has the screen that I'm sharing, and on the top right corner has on the top right corner has the somewhere there, maybe a little bit there or here. I don't know how big it is. I think it's small, maybe like this. It has the camera that is looking at me. Okay. When the Zoom is recording, it makes 3 recordings. One that has only the screen I'm sharing, one that has only the instructor camera, and one that has both. I take one that has both, and I also post it under the module, as I showed earlier. Okay. There is when I write on the screen during the class, I make a conscious effort not to write here, where I said that not to write here, where the camera will be. So I try to avoid that. But I know myself, I will make that mistake. At some point, I'm going to write behind that screen. It won't be, you won't be able to see it when you view the video. In that case, I suggest you go to the Zoom room, go to cloud recordings, and it's gonna have it there, all 3 videos. And you just choose the one that has the screen that I'm sharing only, and you check from there. That's the only thing you need to do to get it. Ideally, I'm not gonna write behind that area. But, you know, I will make a mistake at some point, I'm going to write. So you have to call. If there is somebody here online, if there is online audience, it's good that they can tell me immediately when I make a mistake. If not, yeah, go there, find that video. or let me know and I will direct you to it. And the other thing is that since we're a small class, I don't expect you to raise your hand or anything. Feel free to just pick up. Yeah, I'm not gonna get bothered if you interrupt me. All right, so I think we covered everything logistics-wise. For the remainder of the time, let's look at, I have some topic of an old paper I wrote 3 years ago, titled Excellence in Petroleum Engineering, about items that elements of our discipline that I guess you guys must be interested on just as much as I was when I was in your shoes, and I still am. So, petroleum engineering discipline in the higher education has actually a long story, longer than people may think. The first petroleum engineering program was established at the University of Pittsburgh in 1910. Actually, the first class titled petroleum engineering was taught in University of Birmingham, or Birmingham University in the UK, in the late 1800s by a former president of Anglo-Persian oil company. So imagine VP, CEO retiring, going into university and teaching a geology class titled petroleum engineering. That's how it started. So 116 plus years of history. It's actually more like 126 plus years of history for our discipline. Sadly, we have been victim of negative influences from both outside and inside. We have self-destructive distractions via non-oil and gas fashions, as I call it. They damage our discipline, and we are in the danger, facing a danger that petroleum engineering will be forced to phase out while more and more oil and gas is being produced worldwide, and have a similar fate with what mining engineering had. In fact, people now are trying to bring mining engineering back, but it's a little bit too late. Now, every time oil price drops, people are talking about the future of petroleum engineering education, and they are skeptical about it. And Babadaki, who's a professor somewhere in Canada, in 2023 put a paper where he presented the number of publications talking about the future of petroleum engineering versus the price of oil. And I don't necessarily agree with his numbers in terms of the gold bars. I think there were much more than what he states. For instance, I don't think that 2020 was only 4 publications talking about the future of petroleum engineering education. I was the editor-in-chief of the way ahead at the time. I myself wrote 2, or maybe at least 1 certainly. I don't know how he measured them, but I certainly agree with his trend qualitatively. As the price of oil goes down, the number of publications discussing the future of petroleum engineering goes up. That's for sure. Now, the paper, I called it Excellence in Petroleum Engineering, and it was presented in 2023 in SPE's flagship annual technical conference and exhibition. It was in San Antonio. I shouldn't be saying upcoming here, to say 2023. It's composed by 10 truths, which is 10 cold, hard realities of the modern day world. Okay, and it's structured as an upside down pyramid. Okay, we start wide and we go narrow. We narrow down. We start truism 1 to 4 involve global themes influencing petroleum engineering externally from outside. Okay, these are big picture stuff. Then we narrow down 5 and 6 are non-oil and gas matters that impact petroleum engineering internally, negatively impacting. Truism 7 through 9 involve petroleum engineering education and its future. Truism number 10 wraps things up. Okay, finishes everything. So I can send you the paper, or you can find it in One Petro. If they ask you to pay for it to download it, let me know and I will send it to you. So truism number 1 is that we are not running out of hydrocarbons. Every year, BP is gathering data for energy production, consumption, generation, etc., worldwide, and is publishing it at like late June, early July. And it has been doing that since 1961. Nowadays, they are doing it independently through a subsidiary called Energy Institute. It belongs to BP. It's basically BP. Nowadays, Exxon does the similar thing. Chevron, Wood Mackenzie, Accenture, a lot of people publish their own data, and many of them are willing to give you their projections. You know, they would love to do that. But most of the time, even with BP, same thing. They are very good at collecting data. They are very bad at doing projections. IEA, the International Energy Agency, as well. Very bad at doing projections. We see here with the green line, the oil reserves normalized by energy consumption per capita, and the red line is the natural gas reserves normalized by energy consumption per capita. They both show upward trends. Okay, in fact, remember that reserves is the amount of oil that is economically and technically extractable at the current price environment and technology availability. So this thing changed. In fact, I do remember from my time I was studying for Petronbol. I remember in 2002, the oil reserves globally was something like $1 trillion barrels. And in 2013, it was 167. Okay, it went up by 2/3 within 13 years. So it's like we are almost finding more oil than what we consume as time goes by. In fact, right now, and I don't think any serious person would disagree with that the market has a lot of oil in it. There is a lot of oil in the market. Now, the first allegations of running out of oil was in the 1860s, and it's ironic, only 6 years after the first oil discovery in the United States with Colonel Drake's well in Titusville, Pennsylvania. For every barrel produced, roughly 2 remain underground, sometimes more than 2. We have centuries of oil and gas beneath our feet. And natural gas has been evolving as the fuel of choice for this century, slowly evolving, slowly but surely. And there is a BTU disparity with oil. That is, if you take the price of gas in terms of its normalized by its quantity, you pay less for a joule of gas than for a joule of oil. And some people, especially in the mass transportation industry, will take advantage of this discrepancy. it started about the time of the shale oil and gas revolution in the US, but it had ripples worldwide, globally. Basically, BTU price discrepancy, we call it. The 1 BTU of natural gas is cheaper than 1 BTU of oil, same amount of energy. Truism number 2, there is no alternative to hydrocarbon forms of energy in the foreseeable future. I took the consumption data for every year, the first year of every decade, although it can be argued that the 1970s is the ending of the 1970s, the ending of the 60s. But anyway, I took 1970, 1980, 90, 2000, 2010, 2020, and then because 2020 was a weird year, I went 1 year back and I did 2019 as well. And with purple, I did the consumption, I colored with purple the consumption of the fossil fuels, the traditional forms of energy, that is oil, natural gas, and coal. That's what we are trying to, they try to decrease as much as possible. And as you see, even though they try to decrease it, it went from roughly 200 exajoules in 1970 to something like 500 exajoules in 2019. That's about a, what is it? 150 times growth. No, 200 became 400 and then 50. That's like 150% growth over, what is it, 49 years? Oh, sorry. Yeah, 49 years. I mean, that's a lot. That's a lot. Even though the proportion of fossil fuels in the energy mix it went down from 94 to 84, the absolute amount went up by 150%. This is important. Then with orange, you have the amount that they try to increase as much as possible, and that is renewables. Things like biofuel, biomass, solar, wind, geothermal, stuff like that. You need a magnifying lens to see it, but more importantly, you know why I use consumption data and not generation data? So that it counts what goes on the energy grid, not what is being generated and dumped, etc., etc. Because those energy sources like solar and wind are highly intermittent, and they have low energy density. So you need to produce vast amounts of it to use a small portion, a good portion. And you see that here. With the solid lines, you see the amount of that energy being produced. And with the dotted lines, you see the amount that actually goes to the grid. Many times, when you read articles that says, oh my God, so much percent of our electricity comes from, of our energy comes from solar and wind, many times there are generation values that they are published, which they look big. They publish the solid lines, not the dotted line. Okay, and the discrepancy between the solid line and the dotted line has nothing to do with technology. It has to do with the nature of the source. Okay, it's an intermediate source. Okay, no matter how much they try, this is what you can put on the grid. I mean, it's that's the nature of it. Now that we have seen that, let's take the public spending, the spending by the government of of IEA countries, International Energy Administration, International Energy IEA. It's an administration, no. Not to be confused with IEA. So let's see, EIA, International Energy Agency, okay? It's headquartered in Paris and has 34 country members, mostly from the first world, okay? If we take their public spending, that means spending by the government, and we divide it into the same three categories, fossil fuels, renewables, and other, you're gonna find a big discrepancy, like they spend a lot more for the orange stuff that are renewables than the purple stuff. Now, for the yellow stuff, it's different for each plot. In the plot on the left, you have nuclear, hydro, this kind of stuff. On the right, when you have the spending, you have transmission, electricity efficiency, carbon sequestration. So there is a lot of stuff that are yellow, but would really be like orange on the with the thinking of the other of the plot on the left. So there is a massive chasm between the two plots. You use mostly fossil fuels, and but you are investing very little in them. So that's something that doesn't look very right. Truism number 3, USA is under a chronic, self-inflicted socio-economic decline. It's a very sad one, actually. I have this plot, I made this plot, which is has energy consumption per capita on the horizontal axis and CO2 emissions total on the vertical axis. The horizontal axis says roughly how rich you are as a country on paper, and the vertical axis says how dirty you are you are seen as. And with the circles that are green and cyan is the global values, and with the squares, dark blue and red, are the US values. Now, very importantly, US is included in the global values, so its global values is not, it's not rest of the world values. And also another thing is that CO2 emissions is total CO2 emissions, is not per capita. So it doesn't take into account the population growth. And as you see, the US on first glance appears to be more energy efficient than the world, the globe, the world per se. But when you hear the word efficiency, pinch yourself. It doesn't necessarily mean something good. Because there is something called Jevons paradox. And is manifested, I think, in this little U-turn that the US appears to be doing at the year 2000. They go from, or we go from big increases in energy consumption per capita associated with small increases in CO2 emission to big decreases in energy consumption per capita associated, small decreases in energy consumption per capita associated with large, small decreases, what am I saying? Large decreases in energy consumption per capita associated with small decreases in CO2 emissions. Why is that the case? Because the goal changed. It went from becoming more energy rich to becoming less dirty, in inverted commas. And it cost a lot energy-wise. There is a lot of opportunity cost, as we say in economics. This energy, these emissions could have been used to generate wealth. And it's something called Jevons paradox, which we're going to discuss later on, the next slide. But that's what is basically depicted here. So, truism number 4, conservation will not lead to lower consumption levels in the long term. And that's where Jevons comes into play. He was an economist from Britain in the 1800s. He had a master's in economics, and he looked into coal consumption data and came up with this paradox that said that the more efficient you become at using coal, the more coal you end up using. So the more efficient you become at something, the more you end up using. And it's not just coal. It has a lot of manifestations in real life, especially with commodities. Commodities is something you cannot really live without. Like oil is a commodity. Okay, no close alternatives. You become more efficient at using it, you end up using more. It's human nature, okay? Think about it. You make a salary, you get a promotion, you get a bigger salary. What's the first thing you are going to do? You're going to buy a better car. You're going to buy a bigger house. The better car will pollute more than the previous car, which was smaller. Right? You're not going to go and buy a more environmentally efficient car. You're going to buy a bigger car. Okay? You're going to buy a sports car. You're going to get a bigger house. You're going to get a house with a pool. You're going to get another house, maybe. This is how nature is. Now, there are some ceilings on Jevons paradox. Like, for instance, there is so many miles you can drive every year. Okay, even if it becomes cheaper for you. I mean, I took something like one, two, three, 4 road trips last year, right? I took one in January, one during spring break, goes to Colorado, one during the summer with my parents, and then one to the East Coast in the summer. Okay, if the gas was cheaper, I don't think I would have driven to Alaska and back, you know? There are limits, okay? And it's not like I cared how much was the gas. Similar, there are some limits, but especially with commodities, the Jevons paradox is true. So when people try to conserve, and it doesn't really matter which side of the politics you guys are, since from Eisenhower until Obama, every president has advocated for conservation. And it's a bad idea. I mean, it doesn't really lead to lower consumption levels. You can see that here, oil price with the solid green line, oil consumption with the dotted green line, and then you have, global oil consumption with the solid green line, US oil consumption with the the dotted green line, black line for the price of oil. Doesn't matter the price of oil, the consumption is fairly predictable and steady for both the US and the globe. Yeah, it dropped a little bit at the end during the year of COVID, and then went back up. Truism number 5. Do I have time or shall I call it? Let's do that. Geologic carbon storage is an unrealistic proposition for dealing with anthropogenic emissions. I mean, it started very humbly in the 90s, and we have now people who are very soon will be saying that they spend their whole entire careers on carbon sequestration, carbon storage. It's a very sad thing because this talent and expertise could be used elsewhere. Yeah, when I was a young graduate student at UT Austin. I used to think not very positively of my classmates who were, well, I was sad for my classmates who were researching carbon storage. Now, even I have some projects that are related tangentially to carbon storage, but this is not something that has a free market foundation. Proper modeling of bulk CO2 injection must be done with no flow boundaries. It really yields minuscule storability. Okay, and when I say minuscule storability, I really mean less than 1%, fraction of a percentage. Okay, only a stupid person will engage into this kind of activity, but they will because the funding is plenty. Enhanced oil recovery, which is a method used to extract more oil from underground, similar to the paper I got the award with Malek, the student Abdel Malek, is on EOR. You can use CO2 to flush oil from underground. It interacts with oil a certain way, especially when it comes to sandstones, but the amount of oil of CO2 that stays underground is so small, it doesn't scale. You cannot say, I will produce CO2, I will inject CO2 and pick up oil. Doesn't make sense. Waste of time, but plenty of fun. Now, what I work on a little bit is can you displace brine in aquifers with CO2 injection? And this is something that increases the storability from a fraction of 1% to something like 6 or 7%. It's good idea. It makes more sense, but then you have the added issue of what are you going to do with the produced brine? What are you going to do? You can desalinate it and sell it to people who need water, drinking water, maybe, but most places they have cheaper options. You can desalinate and put back to the aquifer, but then you don't talk about 6 or 7%, you talk about much less. Or you can re-inject it elsewhere. And then you are dealing with other problems. And of course, you are going to use more, you are going to produce more CO2 to deal with that brine. So that's a big headache for other people. And don't take me for granted. Also, the IEA's prediction for the old net zero at 2050, it even says that the net zero scenario has, is severely lacking, So anyway, I will carry on next time. So thank you very much. I will post the video online and we'll let you guys know.